Okay, so in the bell work problem, what we did is we compared three different things, 2 TV screens and a movie screen, and we determined which two were similar. So what we're dealing with are similar figures. Similar figures are shapes that have the same shape, but not necessarily the same size. So now we're not necessarily talking about congruency, where they have to be the same. Now they just have to be similar. Does anybody know the key term when we talk about similar figures? They have to be what? What's the term? Tyler? No, not congruent. Similar was the movie theater the same size as the letterbox? No, but they are similar.
Same shape.
Not because the same shape, but not necessarily the same size. But what are we going to look at? What do we want to see if they are similar? If they are in what? In proportion. That's exactly right. Okay, so we have another vocabulary term. Okay. So in order to have similar polygons, first thing has to be true is that the corresponding angles have to be congruent. Alan, when we talk about the concept of corresponding angles, what does that mean to you? Yes. Gabby, can you help Alan out? What does it mean by corresponding angles? When we talk about corresponding angles on two polygons, what are we talking about, Gabby? You know? There's nothing to look at. Does anybody know? Bill?
Oh, like in two figures when that's what he said. Like A, B, C, A, and then those ones F and G, whatever, F and A.
Exactly. That's exactly right. Very good, Bill. Corresponding angles mean they're in two different figures, but they're in the same spot. So if I have two rectangles, A, B, C, D, and then I have another rectangle, E, F, G, and H. Angles A and E are corresponding angles. They're in the same spot, but on different figures. Okay, so you have to know what corresponding angles are in order to understand the concept of similarity. So what we need corresponding angles congruent, so the same angle in the two different figures have to be the same measure. And then the sides have to be proportional. What we mean by proportional is if this side is 2 and this side is 3 and this side is 4, then this side would have to be what? 6 is correct. And what we're going to do is we're going to set up a proportion. We're going to say that 2 is to 4 as 3 is to x. Or what you can also do is you can compare two sides on the same figure. It doesn't necessarily have to be figure to figure. So if we get a proportion, we could say that 2 is to 3 as 4 is to blank. And then solve the problem and figure out what the length of that other side is. That's exactly what we're going to be doing today. Okay? All right, I do have one more vocabulary term. Okay, so scale factor is the ratio of the corresponding measurements of two similar figures. So for example, if I have two triangles,
Draw the diagram.
I would. Okay, just as a housekeeping issue, if I wanted to indicate that these two triangles are similar, I would write it that triangle ABC, when you have one squiggly line, that's the notation for similar to. So just remember the squiggly line with an equal sign underneath it means congruent. Just the squiggly line by itself means similar. Yes. Similar to. There is no such thing as two squiggly lines. There's this squiggly line with an equal sign underneath. That means congruent. Just one squiggly by itself is. Alright, now, when we talk about the scale factor, what we're doing is we're comparing sides of the two different triangles. So if I look at sides BC and YZ, so the length of BC is 20, and the length of YZ is 8. So I can simplify that, divide everything by 4. So what I can say is that the scale factor of the first triangle to the second triangle is 5 over 2, or 5 to 2. And what that means is that each side on the bigger triangle is 2.5 times larger than each side on the little triangle. Or put another way, to get to the bigger triangle, I take the value of the small triangle and multiply it by 2.5, or 5 over 2. And if I want to go from the big triangle to the little triangle, I would divide. So if I want to go from the little triangle to the big triangle, I'm going to multiply. From the little triangle, from the big triangle to the little triangle, I divide. Okay, does anybody have any questions? Okay. Now, one of the things that you're going to see on the end of course exam that gives students all kinds of fits is identifying similar angles and sides when the triangles or whatever figure don't look the same. So what I mean by that is, here's a triangle. This is triangle T, S, and R. Here's another triangle, M, P, and N. And we are told we are told that triangle MNP is similar to triangle SRT. And the question we want to know is, what are the pairs of congruent angles? Now, what the problem is here, does anybody see a problem with picking out the angles? The way they don't look similar because one triangle is facing up and the other triangle is facing down. Now, there's two ways around this problem. Number one is to redraw this triangle, or recognize that the similarity statement tells you which angles are similar or which angles correspond to the other angles. So, yes, Bill. Here, that's a T. So by looking at the similarity statement, so what we do is we say that angle M is the first angle in this triangle. Therefore, it's going to go with angle S, which is the first angle in this triangle. So we could say that angle M is congruent to angle S. And that angle N is congruent to which angle? Angle R. And angle P is congruent to angle T. Okay, so when we're talking about the angles, right, this is for congruent angles. To find the congruent angles, we use the figure, we use the similarity statement. Okay, you can also use the similarity statement when deciding which sides are proportional to which sides. Again, one thing you can do is redraw this triangle. Now that you know where the angles go, now you can redraw this triangle. Well, we know that if I draw the triangle so it's facing the same way, I know that angle M is going to go with angle S. I know that angle N goes with angle R, and I know that P goes with T. So that's, again, one thing I can do is redraw the triangle so that now they look the same. They're facing the same way. Now, if I want to know what side is proportional to TS, I know that it's what? If I say TS, TS is proportional to what? PN. It's equal. It's not congruent. And then, what else can I say? I can say SR goes with which side? MN, thank you, Jonathan. And then NP goes with RT. The other way to do this, does anybody see another way to do this problem? Does anybody see another way to get this answer without redrawing the triangles? Oh, I understand. Tyler? There's no numbers here. There's nothing to cross multiply. Look at the similarity statement. We know MN is going to correspond to SR. We know that NP corresponds with RT, and that PM corresponds with TS. So those are the two different ways that you can determine what's similar, what's congruent, and what's proportional. Okay, does anybody have any questions? Okay. let's try one.